Hello everyone. Today I'm going to show you Python programming on Linux platform, and in particular I'm going to talk about Python basics. Uh, we're discussing variables, data types, expression, assignment statement, if statement, for statement, while statement. We're going to be also discussing for and while loop, which is also a statement that you're going to do. And we're going to have video number 3. We already did the video number 3 on Windows platform. Today is on Linux platform. We're going to discuss Linux platform Red Hat 9.3 RHEL release, Red Hat Enterprise Linux version 9.3. So this is video number 3. And then the demo is going to cover Jupyter-lab as well as Visual Studio Code on Python operating system, Python programming language on Red Hat operating system. Sorry about that. Thanks for watching the channel, and let's get started. Before we continue, I want to introduce you to the channel. MyWebUniversity is my channel. So when you come into youtube.com at MyWebUniversity, the handle is MyWebUniversity. You're welcome to watch all these videos. There's a lot of them. So if you go on the playlist, I have a group of playlists, whether it's Red Hat, Enterprise Linux, or some kind of a direct path to Linux Ubuntu, or direct path to Linux shell scripting, or the direct path to Python programming languages, Windows operating system, virtual machine, and VirtualBox, all kind of documentation and videos that are available on my channel. And also under the videos, the latest ones are already posted here. The most popular ones are also here. You can see this video is watched about 4.2K. That's not as popular as it should be, but once people know about it, they all make nice comments and watch it. And then similarly for the advanced and other ones. So there's a lot of nice videos for long hours, and then you're going to learn from novice to advanced levels. Please make sure that you watch them and enjoy them and learn it. I make these videos for your education purpose, whether it's college kind of education or career-wise, that you could help yourself. So this is the channel, and that you can watch videos and subscribe, as well as on my website I have a lot of documentations and that I posted here. You can see there's one book that I wrote called The Direct Path to Linux Ubuntu. It is the entire 11 chapters online. You can go on each chapter and practice. For example, if you go to advanced level, then all those videos that I was just telling you that is there. This is one of those video. This is video number 1 of chapter 4. This is video number 2 of chapter 4 and up to chapter 8. For each row here, I have one video. So 8 of 8 would cover this one. 1 of 4 is 1 of 8 of chapter 4 will cover the first one. And then you can practice them online also. So every command that you can click on, if it is security related commands, I'm not going to give you option to run it on my server, but I do give you examples like this documentation that you can practice it and understand it as if you're sitting in front of a Linux machine. At the bottom of it, for each of the command that you learn, you can click on it and just get the manual pages for that page in here, like that. And then similarly, if you go like for group add, you could see the documentation for group add. And also you could also search for command, like let's say you search for Python here, you will get the Python information. And then if you say, well, what about Python 3? Python 3. So if there's manual pages for it, it will be just displayed here for that. And then in addition, on the website table of content.html, when you come here, For example, on Red Hat Enterprise Linux Rocky, for a lot of these technical documentation that are open to you if you log into a Linux server, in particular, in this example is Red Hat 9.2, that you have to be logged on a Linux Red Hat server. But I made it so easy for you in a PDF format. So you just visit my website and you have internet access in a browser of your choice, and you just click on it and you just read the entire PDF in a nice format here. So if you're just interested, like for example, on the Python, you could just search for Python 3, and then it will just go this documentation here. And you can read the entire page 12 of them. And then if you're just saying, what about other compilers like GCC compilers? And then here you have it. And this one might be a little bit larger, 678 pages. So the entire thing is available for you in a PDF format. You don't need to buy books. You just come in here, visit, and everything that is general public license. And instead of you logging into a Linux server or a Rocky Linux Ubuntu or something, I just have it available. So if you're looking for Rocky Linux, here's the documentation. Every one of them you click, you get the detail. And I give credit to MyWebUniversity, my website, Python, and Rocky Linux manual pages, as well as a PDF, free PDF library of Python. And then you can always resize this one to see a different font and different size, and you can read it. There's also like C++ and header files that you can get information. So like whatever you click here, you get the manual pages, standard.io.h or stream.h, all IO stream.h or something. And then the same thing for Ubuntu, manual pages available here. And then whichever one you gave, notice that this one is Ubuntu. So I gave the manual pages of Ubuntu credit for Python, free PDF, and MyWebUniversity. And here's the document that you are able to view. So in addition, if you're running shell scripting, you can watch chapter 5 and then practice the videos here and then run the commands. And for some of the commands, you actually could run it and you get the output here. And if you are, let's say, I'm going to make the screen a little bit bigger, you can type in the command here, uname -8, you will get the output. And then whatever command that you're just sitting in front of a browser, you're running Linux command. Linux Ubuntu in this particular one. And then if I say wd print working directory is there, df-h, any command that you type in, it will just run the output for you. So it is dynamic. If you just run date right now, you can see today is December 19th, and then 1 minute later, you run date command again. Notice this one is 0044 on 19. If I just run the command again, that time changed right here, 33 changed. So 33 seconds. Now, if I run it again, you see 39 seconds. And then similarly, if I say calendar 19070, the epoch calendar, it will run that command for January 9070. If I say calendar of this month, it is going to show. If I say calendar, let's say 2/1998, whichever calendar information that I requested, February 1998, it will just give me that information. So the commands are running this one. And then I'm going to just actually go to Python now because there's a lot here that you could practice. And all you need is a browser, access to the internet, and the desire to learn. You come in on my website and everything is provided to you. And then you can learn chapter by chapter by coming here, for example, let's say table of content.html. You can see here chapter 2 is basic Unix command. Chapter 3 is intermediate Unix command. So some of the commands that I showed you, you can practice it there or just type in here. Like df-h command, here, df-human readable, you click on it and it will say, this is the command, here's the output. And then if you just say, what about manual pages for it? If there's manual pages, you can get the manual pages also. And then df-k right there, and then you can get that. So for each of the command that you run, you can get the output as well. And then change group and change permission. Since the options is a lot of security related, I'm providing you documentation here. Like if I do change ownership or change mode, you can see I'm giving you these tables, explain all the permissions, the UMask, and then what the octet number, read, write, execute, what they means and how the octets are calculated and the commands and how they work. I explain it on this nice table. It's like a book, basically. And the whole book is online, as well as for each of these ones, I have videos that you can watch, as well as you can practice them yourself. So like if you look at disk usage, you click on it, now you see disk usage example 1, I say minus sh star means give me a disk usage on summary in the human readable, and it gives you the size of each of the file in a very nice format and calculate it for you. And then in addition, when you go to the disk usage command, before you come into the example for each one of them, the manual pages are here. So manual pages will just give you the command. So like earlier, I was showing you the df command. If you are not on the example, you could do the df also the same thing, get the manual pages. So if I go back here and then click on df, and then right here, I don't go to the example, I get the manual pages. So each command has a what is section that tells you what is this command is used for, examples, and then you can also get the manual pages for it. It's pretty good for teaching you online everything, go command by command, and then for each chapter you go there, you will get a list of commands to practice, and this one is 33 of them, and chapter 2 is also 33 of them, and chapter 4 is about 88 of them. But then each command with the number of arguments and then the parameters, the different examples, there's hundreds of them altogether, or thousands of them when you combine all of them with their examples. This is the website that you can also get it documentation. So here is the video. I'm going to be teaching you the Unix version of Python programming on, in this case, not Unix, Linux. Linux Red Hat, who I'm going to cover tonight for Python programming with basic and other ones. And so the basic that I mentioned here, we're going to talk about Python basic, variables, data types, expression, assignment statement, if statement, for statement, while statement, and we're going to be discussing Jupyter-lab and Visual Studio Code on Red Hat platform. So let's get into a Red Hat machine. And in this virtual box that I have here, on the virtual box, I'm running a lot of Linux VMs because on my host operating system, I have enough, and let's say I'm gonna clear a screen here, say host name. This is algorithm is the host name, and if I say system info, find string /I and say OS name, this one is telling me that I'm running a Windows operating system, and it's Microsoft Windows version 11 Professional Edition with the build version of 10. And also I can get that information typing CMD, that is going to give me the build number too. So the information that I type here is going to give me the OS name information, as well as I can say how much memory I have. And since I have 32 gig, I'm allocating some of the memory out of the 32 gig to the virtual machine that I'm running. So in this particular VM, I'm running Red Hat Enterprise Linux 9, and as you can see, it's Red Hat 64-bit, and it's 8 gig of memory with 4 processor. So you can pre-allocate the amount of resources that you want for every virtual machine when it is running, and there's going to be some resources taken. So if you right-click here on the Task Manager on Windows and look at your resources, you can see the processes that are currently up and running. One of them is the VirtualBox. So if I go here on this screen, you can see right here the performance on the CPU is right now is about 13%, and then 2.9 gigahertz is the speed. And then I have 8 core of those ones. So you can run like command say device manager. When you look at the device manager, all your resources on the system are going to be shown. One of the resources, the processor. The processor, I have 8 cores. They're Intel 7 architecture, 11 generation of mini computer with 3.4 gigahertz speed. And there's other resources that we already looked at from the monitor and the commands here. You can get it from the command line or just from the graphical user interface. You can also just type in about here. So about your PC, you can see that I'm running Microsoft Windows 11 operating system, and then the processors 11 generation Intel Core i7, 8 of them with 3.4 gigahertz. The name of the host is Algorithm. It has 32 gigabytes of memory. Some of it is allocated for the physical host, which is the Windows 11 operating system, and then the other ones are for a virtual machine, VM, and that's called virtual machine, and they're currently running Red Hat. So that is this information. There's a lot more information you can get from all these details, but let's just close this one. I don't need it. I don't need the CPU utilization. This server says it's running, so I can click on show, and then I will get this screensaver. I'm going to type in my password for the user that I'm logged on, which is Wahid, and then my full name is Wahidullah. And right now I'm on Red Hat 9. This is the desktop. You can always click on the change background, and then whichever background you like, you could change it. And then you can play around with the background of your choice. Some of them are very nice and cool colors. Some of them are too much of color, and some of them are also a little bit good pictures and details and everything. So depending on what interests you, you can set up this one. For this video, I chose this one. I'm going to stay with that one, and I'm gonna just click on the activity. When you click on activity, these other option comes in. So the options are now hidden by my Zoom, which I'm going to move up here so I could see also the options. And then now I see the terminal, Firefox, and then file manager, and then software update and help, and then terminal, and then software or applications. So when you click on the application, you see all the application. At this time, I don't need to use file manager. I will do everything from command line. And so I'm going to click on the command here. This terminal comes in. And then I notice the size is a little bit small. So I can do Shift Control plus, and I could resize it. So that's a good size. I'm going to keep that one right there. And then I'm going to say host name. It shows that localhost of local domain name. And then I say ID, I'm logged on as Wahid. And then if I say ID-UN, it says username is Wahid. ID group name is also Wahid. And then if I say get and password Wahid, I have my shell as bin bash, and then my home directory as /home Wahid, So if I just do a PWD, it shows home Wahid. If I just say echo $home, will also, so it shows my home directory there. Similarly, if I say echo $shell, it says bin bash. Similarly, if I type in PS process, it shows that bash is my shell, my current shell. So if I just say echo $, it will show the process ID of 6470, which is that. So there's a number of things you can do. Like if I clear my screen and go to this back command here, say Wahid, for example, instead of this, remember that I say ID-UN, so I could say sub shell ID-UN, and that output of this command, which is Wahid, is going to be passed to the password. So whether you run it like this with a static command, a string Wahid, or just pass it on from the environment, get it, you get the same output. Similarly, like if I just want this one with the backtick, this character is called backtick, you can get the same output. So at this time, I'm gonna clear my screen and I say, okay, hostname is this, and uname-a is telling me that I'm on a Linux operating system. Linux-o is gonna say GNU Linux, sorry, and uname-o is gonna say GNU Linux. Uname-a was giving everything. Uname-a was giving everything, so uname-n is the node name, which is localhost.local domain. But the local domain, the first part of it is the host name. So I could say cat -d dot minus F1. That would give me localhost. If I want to say the local domain, then I give the full qualified host name and domain by just typing uname-n or host name. And then also I could say uname-s, that's the system name. Uname-m for machine type, which is x64 architecture, which is VirtualBox, and then uname-r for revision, the built version, and uname-p for platform also is same thing as machine type, it's 64-bit, x86 platform, and then there's a number of them, so you can get all of those ones. And then if I just say uname-v for the version is symmetric multiprocessing. So if you need anything with the uname-help, will give you all the information. So -a or -all will give you that output, or -s or -- kernel name will give you system name. And you could just practice those ones as you want. The other file that is important on the etc, there's two files. One is called Red Hat release file, and one is called os-release. So these files, os-release is pointing to this path, user bin. So when I want to see the detail of the OS system, then I can do cat -n etc os-release. -n means show me in line number. So on line number 4, it shows that the distribution is Fedora. In line number 7, it says that you're running Red Hat Enterprise Linux version 9.3, and the code name is Plot. So you could see that this is detailed. If you want to just get only the Red Hat -release, then it's only one line, and it says you're running Red Hat Enterprise Linux version 9.3. So now we knew that what operating system we use. Let's find out the Python version. So Python -v, it says that I'm running 3.11.5, and then Python version will also say that 3.11.5. But notice if I say which Python, it says that file. Before I do that one, let's do which Python 3. Notice that I have user bin Python and user bin Python 3. So I want to say that under user bin Python star, one of them is a symbolic link, and Python is symbolic link to Python user Python 3.11, but Python 3 is symbolic link to the previous version 3.9. The reason that I symbolic link this one on one of the video I showed you on the subscription manager would be broken if you install Python 3.11. All of a sudden you notice subscription manager doesn't work. In order to fix that one, I had to just look it up on subscription and access.redhat.com to see what their solution is, and their solution is not acceptable as a valid kind of way to and just say, well, we upgraded Python to 3.11. Now the Python 3 has to be symbolic linked to Python 3.9 because Red Hat, when it was written for 9 version. So Python 3.11 is not going to work with the subscription manager. You have to symbolic link this. But the Red Hat developers should know that when you do something like this is patching. This is not a fix to the operating system because a lot of the developers, there might be hundreds of developers or maybe 10 developers with 1,000 lines of different Python program languages. I mean, for Python programs that they might be pointing to Python 3, assuming that since Python 3.11 is running, they're writing the code for Python 3. So the first line of the program, if it's shebang user bin env Python, and then that's expecting user Python 3.11, then that's okay. But if they're using shebang user bin env Python 3, and they're expecting this one to be pointed to the latest version that was installed, 3.11, yet this is symbolic link to this, then their code, whatever feature on 3.11 is available, it will not be available on 3.11 because you're using Python 3. So if I just say like this, Python dash version, you can see it's 3.11, but Python 3 is going to say 3.9. So shebang, on the first line, shebang user bin env slash space Python will run 3.11, and Python 3 will run the interpreter Python 3.9. That's the part that the developers are not aware that this symbolic link is already making the subscription manager work, but not the entire code that they wrote for 3.11. So that is something that please see if you can fix it on the next version so it doesn't break subscription manager. Right now, I have done it with symbolic link, which is a solution based on Red Hat documentation. So let's get to the point that what we are doing with Python. So in Python, when I say which Python here, file user bin Python star, you can see some of them are executable and some of them are symbolic link. The one that are executable are actually says executable link format 64-bit. The symbolic link are just pointing to this version. These 3.9 and 3.11, they have to be actually binaries that are there. Like this one is 3.11 is executable format, and so is user bin Python. And that is how those code works. And then at the same time, for this one, you can also get LDD on the user bin Python 3.11 to get all the dynamic link libraries associated with that one. You can see that. Similarly for 3.11, you will see that libraries that are attached, libc and libmath and python 3.11 shared object file. There's a lot of details with other proc file system that you can get details of this one, PLDD and other ones. But at this time, I'm going to show you more Python than just Linux. So Now we're in this directory. Let's say I want to go to a program slash programs. And notice here I have all these programs directory, different programming languages, and clear screen pwd ls. You can see under the current directory, which is programs, I have a number of other directories. So I could say find dot minus type d, and these are all Python programming languages. But notice that the courses that I taught at pasadena.edu is also under this courses here. I could just go to this pasadena.edu, and then I have a number of courses here. So CIS start, clear screen, ls minus ld. When you want to see the listings like that, you have to say -l long listing, D for directory, don't show the content, you do ls -ld. But if you don't put the D, it will go to each directory, it will show the content. So these are the directory, you can see this. You can also do a find dot minus name, and then you could say CIS star, and then minus type D. That will also show this. But then if you just say on this one, do a minus exec, and then whatever listing you want to see on each of these files, you can run like a command here, you could list them also. And then if you're interested to only see the Python under these directories, you could say, for example, CIS start.python. You could see that listing here, but since we're looking for .py, it is a F, regular file, not a directory. So you can see the listing here. And if you want to see one page at a time, you could see this, or you could say 5 more, and then you could see one page at a time also. So the files are there. Inside here, under the one of the directory, clear screen, one of the directory CIS star, let's minus ld, CIS star, it's called the CIS file. So I could say, go to the CIS file directory. Since the only directory is file is that, I could just do a cd this, and it will just go to that directory. And then I will see like, okay, I taught in fall of 2020, 2 different sections. One was this one of them was this one, but I created this lecture section, and then I just put all the chapters one by one on that class for teaching everything that I could have taught in there. So inside here, there's a number of ways you can just practice this. Since this directory is really long, and I made the video already for Windows, if I want to go to CD to chapter 1 through 5, I could get that one, but then notice here, start.py, a number of programs are here. So instead of having this long directory, I'm going to show you a technique that I want to show you Python portability, because earlier we did code on that video that I made here. Let me just show you this right here. This one was all Python programming language with Python basics on all those data type and expressions and Boolean operators and assignment statement, if statement, for statement. But all of that example was done on Windows platform. Now, to show you that code reusability, I want to just, instead of using the Linux version of this one, I want to upload everything that's on this directory. That is last time we did directory chapter start. So look at this one, chapter 1 through chapter 5. I can upload everything from chapter 1 through 5 to that one, so I could show you the same one. But these are codes that were specifically tested on Windows operating system. Now I want to upload this one to see if there's any issue that running the code with Linux operating system. Some of the files might have control M characters, but at the same time, if you're checking on the operating system to see if its OS name is NT or POSIX, then you can look at those example and how you make your code work for both platforms, disregard to what it is. Because Python, all it requires an interpreter. So when you're running it on Windows, you have the Windows interpreter, Python.exec, and when you have it on the Linux, you have Python executable link format binary. And then disregard is a version, and as long as that version of 3.11 is available and your code adhere to the 3.11, you should have everything working. So let's get back to uploading this file. I'm going to go to this directory here, and then let's say I'm going to upload this chapter 1 through 5. So I'm gonna say is copy -r. This first I need to get a source and destination location. So the source is here, the destination is on this one. I'm gonna just come back, instead of this long directory, I'm gonna say go to programs and then go to Python. So this is the directory, but notice on this directory, I don't have a chapter 1 through 5. I don't have that directory, but I do have an IP address here, IP A. It tells me that I'm on the 192 subnet on this local area network on my local subnet, because I configured the virtual machine to be bridged over the host operating system. If you look at this configuration here, under the setting, I configured the network as bridge adapter. So when you do this one, that IP address that is allowed, I could bridge over. So which means that I can get the 192 subnet and I could say is copy -r recursively, and then chapter 1 through chapter 5, all of that one to Wahid at give the IP address of 192.168.254. That's my gateway, and then the particular subnet IP address of the Red Hat machine is .192. So where I want to put it, I want to put it under programs and then Python. And I put a dot, meaning that say the destination has the same name as chapter 1-5. So I'm going to say the password here, I'm going to type in my secure password, and right now the files are all uploaded. So now let's see how fast it was. Now we're going to go back here, and then now we do ls-l. This time we see that chapter 1 through 5 is there. If I just do ls-ld, then you can see that chapter 1 through 5 is there. So let me clear my screen here and do this, and now we say go to chapter 1 through 5. I can say like that, and then there. So now these are the files on chapter 1 through 5, and then if I want to see star.py, you can see that this is a list of all the files that are there. Remember, one of them I said if your operating system is different. So if I just run the same command, myos.py, cd to chapter 1 through 5, and directory myos.py, notice that more on myos.py, this one says that run this command, say shebang Python, and the OS is in this. This is a blind command. It does not detect whether this is a Windows operating system or not. By default, it just said this one. It says run it with Python. This could also work on the Python, because we're saying that whichever one is Python. On Python, there's also aliases that you could set, something I could show you that. I mean, on Linux server. OS name, imported OS name, and then here this is specific to Windows only, calc. That is not a Linux command. So for Linux command, if I just run this program, I have to check on the operating system. If this is the case, then we have to do that. So right here, I could say, I can modify the code and do it on this level, but we already showed you that on the Windows. Today, I'm going to show you this code, how you make it compatible here on the Linux side. So here, if you run the code, say Python myOS.5, notice the calculator opens because I add the calc command. And then the next command was pep command. It ran the pep command and it give you the output. And then the last Python-v also give you the version here. And then pep list is gonna give you that one. So this working like that, but I wanna just do the same thing here. Notice that if I look at the content of that file, I say clear the screen. So ls minus ld myOS.5. And that's the file cat -n myOS.5. Notice that the file is there. There's an end of line character at the end of it. You can also do a vim on myOS.5 visual interpreter modified or and the enhanced version of it, a vim of BI, is going to show you this. If I do a set list, notice that there's a new line character at the end of each of them. So if I say set no list, and I want to set my line number, and then you can see that there's a 6 line on this code. So let's just run it with the current documentation, current way that it is there. If I just want to run that one, I could say Python myOS.5. It will try to run the calc, but notice it failed on the calc. And so this is the pep command, and then says calc command not found. Because when you say os.system, this calculator command is not there. So instead of that one, if I say, let me just see extern iCalc, xcalc. So if I say which xcalc, which xterm is there for sure, yeah, and then say, let me see which x clock. Yeah, some of the information, if it is not installed, you can install it, but at this time, I don't have the time to install other commands that are not there, and I want to practice the one that we actually want to do it, and then this is Red Hat, so some of them you have to do the repositories and all those details and to search it, like DNF provides, and then you could say star, then star, and then clock, let's say, for example, see which one is available for it, and then we could do a DNF install the package, and then next clock or other ones are coming. So some of them are going to show here is release the 9 and other ones. But at this time, like I said, I have a lot of other programs that I can use. I don't have to rely on that. So let's assume that we're going to modify the myOS.5. At this time, I'm going to say, I'm going to do it with using vim. So we could say, I'm going to try this as a f os.name is equal in T, then you run these commands. these commands. And then the pipe list, I'm gonna do another one, say find a string slash I, and I'm gonna just search only for one pipe package indexer, let's say for requests. So if we search for that module, and then we're going to do this, and when OS is this, now we have to move this one about 4 columns here. Similarly, this one, and similarly this one, this one, and then you say else, and then the else has to start align here, and then on the else part, you could say os.system, and then at this time I'm gonna say, let's say uname dash a, and then since it's whatever other operating system, but it's not in T, os.system, I'm gonna say cat etc red hat dash release. I'm assuming that it is a red hat release. I did not even check the operating system, so I know it is kind of like cheating. But I will try to show you this first before I do further. So now if I say my os.py, and then it's gonna go to the else part. When I say Python, my os.py is gonna run the uname dash a and also cat etc. Uname dash a output is right here, and then cat etc is this one. So at this time, if I just say, well, I just kind of knew that it was Red Hat, but what if I just want to check this one that it's POSIX or something? So let's do this one. This time, we're not going to cheat. We're going to actually code it to say if it is OS's. We're going to say if os.name is equal POSIX. That is whether it's Mac or Linux, it will do this command. And then at this time, I'm going to also run another command here, say go os.get current working directory. So it is going to print my current working directory as well, and then os.system, and let's do one more command, say post name. Not post name, let's get the calendar command. So there's a little bit different output here. And then this time when we run the same command with Python, you can see the output. So os.name, I typed something wrong. So let's check the elif. When you do the else, that part of the if statement, when you're doing else, this is not else, this is elif. LF. That's the LSEP. And then right here, you could say, if all fails, then you do the else part. And then say, print, we never get here. We'd never get here because either this example is OS is Linux or OS is Windows. So clear the screen and then say, run this code and say os.name, elif os.name. Let me check on this one to see why. Oh, the equal sign, you cannot do equal sign like that. You could have to do a sign in a statement. Is equal sign, double equal sign is comparison. So here we did the comparison, over there we did assignment. It's like assign POSIX to OS name. You can't do that. So that is why. And then when you run it like this, now it works and it'll give you the output that you expected. And so let's do this one now. Let's minus my os.py. Notice my os.py is there. On this example, it's on the chapter 5.1.5. I'm gonna just go back here and then say clear screen directory. and I'm gonna say my os.py, I'm gonna get another version of that file from the server. So I'm gonna say is copy Wahid at 192.168.254.192 programs / Python / chapter 1 through 5, and then my os.py. I'm gonna say my os underscore one dot py, or just number 2. So it will detect for 2 operating system. You could say number 2.5. So it will distinguish between the 2. And then we say, just download it here. Now, if I just say type my os.py is the previous example, but type my os underscore 2.py, you could see that the code is a little bit longer. And notice that this one is gonna run these commands, because first it says operating system is what it is. And since it finds it in T, then it's gonna run the calculator command, Python dash version. This time we're not gonna get a large list. We only find if request is there. So if I just do run that command pep list and then find a string /I, on the worst level, this has to work. And it's gonna give you the request version. When it's going to run that program, Python, if I do that one with the example we did the last time, this time, if I run this one, obviously, that is gonna run the entire command. But if I just wanna run the underscore 2, then it's gonna give you the calculator command as well as a Python version as well as request. So clear screen here, and then this was the output is calculator, and then the Python version and the other one. So if I just say, show me that content of it, you can see it runs the calculator command and Python version and this. And here's the output. I'm just showing you one more time, so you know. The other one was OS. Sorry, I have to show you the other one. Type 2 is this one. And if I run that one with Python, then it will do exactly what we were telling. Calculator is this one, and then the Python -b is this output, and then pep list find the string is gonna say, yeah, we found out request module 2.31.0, and that's the one. And then since the OS name is not POSIX, it's going to show not run this part, and it's never gonna run this command because the first if statement is going to branch only to the section that it runs. If this section doesn't match on the Linux side, it doesn't match that one. So if I'm going here and then I want to say clear screen cat my os.py, since this section if statement fails, then it's gonna just run this section. And this one os.name, if I go to Python, inside Python, it say import os and say os.name, not this is POSIX. Since this one is going to match, it's gonna do the same thing. Here, the same thing, if I go on this one, say Python, and then import os, and then say os.name, it's gonna say 18. So that's why on Windows, put reusability is important, but at the same time, make sure that the operating system and other modules that are there is specific to that module. There are certain methods and certain things that are available. Make sure you use them correctly. So for example, if I say import OS module and then sys.path, I can see that all the path in here. Notice all the path here is C colon something with backslashes, but on the Linux side, let's do this one first. Here sys.version, you can see it is 3.12 sys.version info, will give you that, and sys.platform, it shows you that it's Windows 32-bit, and then sys.executable, it is a Python.exec executable, and then at the same time, if I go back on Linux and say import sys module and then sys. Path, notice that the path is with the forward slashes, and it shows that this is entire list. All right, so I could say for path and sys.path and do print each path. And then when you print that one, you can see one by one. So print sub 0 is this empty, and then print sub 1 is the zip file, and sub 2 is this, and so on. So I could say sys.path sub 0, and that would be giving me the empty list. 1 is going to be the zip one, and then -1 would be the last one. -1, you have to just make sure that you don't put two brackets. It's you can also get the list from like column here separated. So start, if you want to start from 1 to the end, you could do that, or you could start from maybe 3 to the end, or 1 to 3, whichever one you want to print, you can just get that list. The last one is not inclusive. So 1 to 3 would show you starting from 1 and then second, and then the third one will not be included. If you want to include 3, so then you have to change this one to 4. And then that would say 1, 2, 3, and then it stops. For the Python executable, like I say, sys.executable, you can see that is this sys.executable, not sy. Sys.executable, it says that user bin Python. And remember, when we say os.system, and then here, if I say which Python, that would say also user bin Python. The same thing. But notice that the os.system return a value of 0, meaning that this function or this method return a success 0. If the command is not available, like Python 4, that is not a command. Now the return is 256, which is not 0, not success. Anything but 0, meaning that it failed. It did not find. But if I say Python 3, that is there, so it's gonna return 0. If you don't want to see the return 0, you have to do something like this. You say a string is equal, and then you put the command pipe open or process open, and then you run the command, which Python 3, and that's the command. Now the stream, type of the stream, you can see that this is an object of wrapper close, right? OS wrapper. So at this time, it's a stream. I could say output is equal to stream dot read. One of the method that is available is read. So now I can say print output, and that would just show you the user bin Python 3, but no 0. Meaning that the command runs successfully. So dir of a stream, for example, you can see that there's all these methods that are available with it. The double underscore method with it. And that method greater than equal sign, doc method and string method less than sign, less or equal than contains, and so on. And so and the other thing was there was also dir of output. Dir of output, if you say type of output, since it's a string, with a string you can do so many things, right? So like for example, these methods are all available with a string. The double underscore magic method, and as well as uppercase, lowercase, or title, and so on. So if I say print output, the output was showing the user bin Python. Now I can say output dot uppercase. attached method that is attached to it. Upper case, not uppercase, upper. That would change it to uppercase. And similarly, lower. The method lower would just do the lowercase. On C++, you would say uppercase or lowercase, to uppercase or to lowercase. There's all these functions, different names, it doesn't matter. You could just get the list by saying dir of output and the list is all there. Or if you say dir of stream, everything with the stream you can do is there. Help on the, for example, output. This will just show you that this is not anything, but if I just change that one to a string, then I can get the method string there. Sorry, str, and then it will give you a string object related. And those method that you can do everything with them or there, as well as the method like uppercases, as title, as lowercase, and so on. Okay, so that one is explained here. I'm going to quit out of this one. So in Python, you can quit out here. Let's create the alias for Python. Remember, we say Python dash v uppercase or dash version. If I just type in pi, it does not understand it. But on the Linux Windows, if I exit out of here, I can say Python 3 dash v. It works. I type in Python dash v. It works, and then I could also shorten it with Python py dash v or dash version. Doesn't matter which one you want to use. But on the Linux side, if I just say which pi, it is not there. And so if I type in pi or pi dash uppercase v or pi dash version, none of them works because it doesn't know what pi is. But if I look at the alias list, I don't have an alias pi either. So at this time I could create the alias called pi and then user ben Python 3, for example. If I just pointed to Python 3, then now I type in pi dash v, it's going to say 3.9. If I just made this one to only be Python, then I say pi dash v, now it's Python 3.11. But if I just do this one, since whatever is Python is pointing to, that pi dash v is also pointing to. So if I say which Python, you can see it's user bin Python, and then file of the user bin Python, it is symbolic link to 3.11.5, and that's why that output is coming. If I do the same thing with Python 3, now this one is 3.9, so therefore it comes in. And file of user Python 3, it is symbolic link to 3.9. So you can make a symbolic link. So the alias command pi, it is now symbolic link to that. And whenever you run that pi, it's going to run the 3.9.11. If I exit out of that one and I create the alias to be Python itself, now I say pi is going to be running 3.11 because I was telling pi to point to this version, and user ben Python is going to run the same version as just Python does. And so you can also an alias a pi thing. If I just say an alias pi, now I don't have a pi on the alias, so alias pi is not defined. Now if I say pi dash v, it's not going to be known. But on Linux, if you just create a pi and you're going on your home directory here, there's a, since I'm using bash, earlier I showed you $shell is bash, and then ps is there, ps lowercase is bash, and also get env password Wahid is showing that my $shell is default is ben bash. So that means there's a file on my home directory called a .bash or C. And then if I say vim.bash or C, now and look for my aliases, there are some aliases here that I could define, or I could just add anything. So let's say after this one, I could say alias Python is equal user bin Python, and then also alias Py. Let's just call this one Pi, and then the next one is P. So user bin Python 3. One is Python 3, I'm gonna call P3. P3, and the other one is just Pi, and that is Python 3. Now I created these two aliases. So in order for me to execute those two aliases, if I don't run it, I have to source it here, .bash or C. Now I did this one, alias or coming here. So alias P3 is here, and also alias Pi is here. Alias P3 is pointing to that one, alias Pi is there, because I sourced them. So now I say Pi dash V, it will tell me, and then Pi P3 dash V is going to show 3.9. So no matter how many times now I exit out, I don't have to worry about I lost it, because I put it on the .bash or C. As soon as I log into the machine, now my alias are available because I put it on the bash or C, and you can see here. So now I say Pi dash version or Pi dash V. It will say Pi P3 dash V and P3 dash version will show that. So depending on what you want to do on the thing, you can add create aliases for it on the your .bash or C or .csh or C, depending on your shell. If you're using Corn shell, there's .ksh or C. If you're using C shell, there's a .csh or C. If you're using Bash, there's a .bash or C, and so on. So this is the code. I'm going to make one more, this screen bigger. Let's talk about the Python examples that we were going to cover next. So under the programs, and then Python, and then I'm gonna type in here ls minus ld and chapter. So I'm gonna go to chapter 5, 1 through 5. And then when I tab it, it automatically does the string completion. So if I say ls minus lowercase, ls minus ld is store.py, I get a list of all the programs that are loaded here. If I just don't want a long listing of it, I just don't put this one and say, show me that. At this time, all of the programs are there. We can go one by one examples and run it. So there's a number of ways you can run. For example, if you run it Python greet.py, you can see that it says hello Wahidullah, hello Diego Maradona, hello Diego Maradona, the greatest of all time, soccer player, and so on. Messi, Leon, the best soccer ever. Similar, Cristiano Ronaldo is my favorite soccer player also. They're all the greatest one. So is John Cruyff. God bless Maradona, John Cruyff, and the other ones that are passed away. But there are a lot of soccer players that were the greatest of all time. So we are going to discuss, let's say, more on the greet.py. You can see the program is stored with Python here, greet and everything. You can also change this one to say, for example, if I just say ls minus ld greet.py, notice that the file is not readable, executable there. I mean, it's readable, but it's not executable. But so if I just say greet, it says permission denied because I don't have executable permission. But I can say Python greet .py, and that will run the code. In order for me to make it work with that just greet, then I say change mode 755 greet.py. Now I just change the permission, and you can see that it has executable bed set for the owner, for the group, and for others. And so they're all executable. So I can say greet.py, and it says bad interpreter. Why? Because this Python was a Windows and it has a control M characters. So in order to modify that one, then I'm gonna say greet.py. Before, when we were running with Python, we were telling it what interpreter to use. Here we're saying inside the header line of this file, head -1 greet.py, it has this shebang Python, but that's control M character. Why does it say control M character? I'll show you. Greet.py. If you see this one, do you see any control character? No, but there is one. So I'm gonna say set less inside them, and you can see control M character or $sign here. Another way you could see this one, clear the screen, you can say cat -EA and greet.py, and then 5 more. We're gonna do a more. Notice there's a control character here. So the cat command, where there's control M characters, invisible characters, tab, and other ones, this cat -EA will show you everything with all kind of tab delimiters and everything. You can also do a octal dump -C for this one, and then the new line characters on each one of them are going to show this. So the control M on the octal dump is showing us carriage return that's coming from Windows. And then the to carriage return is defined as a control M, and then the last one is $sign. So you could see those lines. At this time, I'm gonna just vim greet.py, and I'm gonna make it compatible to work with Linux. So instead of that one, I'm gonna say user ben env Python. This is telling me that I'm running Python 3.11 with the binary env loading the interpreter Python. So now if I just do this one, clear screen head -1 greet.py, notice that is there. This time, since the file is executable, I should be able to do greet.py and then get the output, but it still says that the interpreter had a carriage return. Since the code came in from Linux side, it just did not understand this one, and it still considered that one as a new line character. So if I just go to the head part of it, and let's see, cat -E A greet.py. I'm gonna try to do this one with just to look at the head section. Notice there's still control M characters here. So in order to just get rid of this control M characters, I'm gonna vim it, say greet.py, because we FTP the or scopy, there's still Windows information here set a list. It is control M characters are not showing actually inside this code. That's a hard part of it. There's a utility called a DOS to Unix and Unix to DOS that you can convert it, but the carriage return is not showing here. So normally, if you do have it, you could say 1 comma $sign. You can use the set command, substitute, and then you say Control V, Control M, followed by nothing. So then you could just say replace it, but pattern control M was not found. Only $sign is shown. So I'm gonna say 1 comma $sign, substitute control V, and then enter, and then do this, and then substitute everything, that was not found either. So 1 dollar sign substitute new line characters, and this is new line characters, and then skipping the dollar sign, and then let's see if that does it not found either. So 1 dollar sign substitute, and this time is new line character like this, and that identify everything as new line character. Then I'm gonna say substitute it to nothing, and unfortunately that just changed my code. It is the new line characters or now nothing there. Let's see if we just save it and say cat greet.py, you see that the new line characters are gone, but actually they're not in the right font format. Cat minus EA and greet.py. And then at the end of it, there's a still control M characters. And then let's just modify the file. We could have just backed it up and do it, and I'm going to just do this. Another way you could do is say cat, type greet.py, and then yeah, there's a lot of information here. I could capture it here and then run it, but it doesn't matter. When you do this for Python slash greet.py, it will run the same code in there. So honestly, the information that is there with different version of Linux and different version of Python and different version of Vim and octal dump or cat command, you will see a different kind of invisible way, invisible character interpretation. One is showing control M character, one is showing dollar sign, one is showing carriage return, one is showing /n. The easy way to do it is to cut and paste the file and then just do it between the two operating system, or just do the same code and run it there. And then on a Linux platform, maybe on a Ubuntu, you will get a different output. And so, and just to test that one, let me just install the Linux Ubuntu also to see if this one, I'm gonna start it and say Linux Ubuntu. And see if Red Hat 9 is having some issue on the Vim editorial to modify control M characters correctly, because it identified as dollar sign, but dollar sign we needed to keep the empty lines there. So I'm going to log in on this one. And this is Linux Ubuntu. I'm going to just go to open a terminal, and with this terminal, I'm going to do Control Shift plus, so it's a little bit bigger. And now let's see, I can go programs, and let's see if I have that file called greet.python. Find dot minus name and greet.py. If we have it already or not, minus type f. Yeah, it is on chapter 5. So on this path, it's already there. I could just go to that one and then paste it and cd to that directory. And now I'm on that directory. It's called greet.py. If we look at that first line of it, head -1, greet.py, and because it has the Python, it's gonna just run like this if I say greet.py, because I'm not saying change the permission with the version of this. But if I say change mode 755 and say greet.py, and now I say greet.py, is gonna say run, but the interpreter is going to be a problem. So it does detect control M characters on this one also. And notice that if I do a cat minus EA on this one, and then cat minus EA, this one, the first line, it has this Python M and then control character there. And there's every line that has a dollar sign for before that one, it is just a control M character. So the way we could modify that one is, let me just say copy greet.py as a g.py. I'm gonna just make a copy of him as g.py. So I'm saying vim.g.py. And then I say set list. Notice that there's no control M characters, but it is new line characters. On the VI, it only shows dollar sign. But if I go on the this and then type in head with the g.py, and g.py, you can see it is detecting control M characters. So depending on the command that you're using, for example, if I do same thing with octal dump minus C and character, you can see the output of them are there. So this is the carriage return is again control M is defined as slash carriage return slash N slash R followed by a new line characters dollar sign. So depending on the shell that you're using, I mean the command that you're using, and g.py vim and g.py, I'm gonna try to do this. Say set a list, and I'm gonna say substitute from line 1 to the end of it, dollar sign substitute, control V, control M, followed by a new line characters like this, and then see if that combination is identified, it pattern not matched. So 1 comma dollar sign substitute control control V, control M, and then now I'm going to try that. That was not found either. 1 comma dollar sign substitute. Let's see if I just say 1 comma dollar sign substitute control V and then control M, that generated the M, but it's not finding it. So if you say the pattern matching, it's not finding it. Let's see if when outside of the set we can do this one. Vim, okay, cat minus EA and then g.py, you can see that these control M character are there. So I'm gonna try to do this one with set command minus E for expression, and then I say substitute, and then I use this brace for it, and then I'm gonna say control V, control M. That's the new line character, and that I want to get rid of these control M characters, and then just do this, substitute it to nothing, and then I'm gonna send the output to g2.py. Let's say ls minus lg.py and g2.py. Notice that the files are a little bit different in size. G2 is a little bit more. Let me see what's going on, and then SF def g.py and g2.py. So there's a lot of differences, but let's see if the lines that we want to do octal dump minus not octal dump, cat minus EA and g2.py. We can see that the g2.py also has $2 sign. So that's why the size is actually added with an extra line. We didn't want to do that one. So why with this one added the control and substitute? Okay, so instead of this, I'm gonna say cat and now g 2.py and g.py. G2. This time it looks like we did it g2.py versus g.py. And it looks like we did it. Let's see more g2.py and then cat minus ea g2.py. And notice that g2.py now is done. So this set command did it inside the Python interpreter did not work, but this was Vim should have worked with $1 control substitute this one to nothing, but here outside of this one when we catted the file it did it, and so now g2.py is different from G, and then you can see g.py and greet.py and g2.py. We have three files, but notice that g2.py file does not have the control and characters. These two are exact copy of each other, so they have control characters. Now if I say head -1 g2.py, it is showing that one. And if I do the same thing with output of this one, and then just say cat minus EA, you can see there's no control M characters. However, if I want to do this one with g.py, you can see there's a control M character. Similarly for the greet.py, greet.py also has the control M characters. So the G2, and we fixed it, is like DOS to Unix. So we converted from DOS to Unix using that set command that I did here, this set command. It cat the content of the file first, then it's gonna just set it. So at this time, since the head of G2.py is correct, if we run G2.py, it will run okay. Permission denied because G2.py is not executable. So we say chain mode 755 G2.py, and then we run it G2.py. If it's still gonna say some issue, then the bad interpreter, this time it's because of this head -1 of it. You see, it says shebang. This is Windows syntax. So I'm gonna modify that one, say vim g2.py, and then you say use a shebang, use a ben env. Now do this one, and then we just say head -1 g2.py. That's a Linux format saying that wedge envs run this user ben env to load the Python interpreter, which Python, and so Python Python-v, it shows you that the version. And then if I just run it now with the format that I wanted to run it, and V is still not working. Python. So let's see, Python -v is there. Vim and g2.python. I'm gonna just not load it through env. I'm gonna say like that. That's path to this. So now say g2.py, and it's still bad interpreter. No such file or directory. Am I typing the user ben Python incorrectly? Let me see that. Which Python? Oh, file user ben Python. Python 3 might be there, but not Python. Yeah, Python 3 is there, but Python is not. So I could create that one, that's why. So vim g2.py, and then we could say user ben env Python 3, because Python was not symbolic link on this one. So that's why I say that these kind of distribution, whenever you install it, there's Pi on Windows and then Python and Python 3. And then Linux, Python might not be there because Python 2.17 was pointing to it, and then sometimes they make it an alternative option. You just have to look at your environment and make the permissions based on that one. Let me show you how to do that one. So here I'm going to say head -1 G to the pi. This time this should work, because if I say user ben env Python 3 will load the Python 3 interpreter. That way, if I just now run this code with $/g2, it also works. So we fixed it, and this is how it is pointing to. If you want to use instead of Python to Python 3, and so when I type in which Python 3, this is available. Python 3 dash version is also available. Python dash V is also available, but not Python this. This is showing the version, but when you are doing with a loader, say user ben Python dash V, it says no such file or directory, because the which Python is not returning anything. Which Python 3 will return something. And then unless -l user ben Python star, you can see there's no binary Python. So if I just root, I could make a symbolic link to it. I could say sudo su dash. Now I made myself as root. So I could say id dash un. I'm a root at this time. I could say link -s -f. Force it if it already exists there. User ben Python 3 to user ben Python. Now this time I created. Now which Python will work? Python dash v would work. Python dash version would work. And then Python dash version would work. So if I just exit out of this one, I'm on the same directory. Now cat head -1g2.5, you can see it is Python 3. So Python 3, at this time, I'm gonna vim this one, say g2.5, and I could say Python, this one would also work now, because head -1 of this one is saying Python, since which Python works, and therefore when we run it with g2.5, it will also work. So that's how you fix those issues. And then the set command that we use, we could use the same set command on the Linux side. So let's go back here on the Linux side on Red Hat, and then we say on algorithm or Red Hat, let's log in here again. First of all, the greet command is messed up. I'm going to say rm greet.5. I'm going to just find another version outside here. Say find dot -name greet.5, and then -type f regular file. It is not in this directory. Let's see if it is somewhere here. Yeah, we found it here. So I'm gonna copy it in the Python directory. I'm gonna say copy. Let's go to chapter 5. I'm gonna say chapter 1 through 5. And then I'm gonna say copy slash I think we were on the slash programs slash Python slash, I'm gonna say Pasadena, this file, copy and then paste it. We're gonna name it same thing here. Widen programs, Python, Pasadena.edu. So I'm gonna say find dot slash dot minus name greet dot file. This is the path of that file minus type f, and that's the path. So I'm gonna say copy this file. And then I'm gonna say the same name. And now I have greet.py. Remember the set command that we used? I'm gonna try that one also, head -1 greet.py. It has that line, but I'm gonna modify that one. Since which Python is working here, user ben env, I'm gonna say vem greet.py, and then I'm gonna just change this one to user ben env and then Python. So now that program works, but notice that head -1 is still, if I just say cat cat minus EA, and then look for the grep minus head -1. If I look at that one, see there's a still control M characters on it. So if I just want to see all of them, then you see there's a lot of control M characters. In order for me to get rid of the control M characters, what I did on the Linux side, I capped the file without the -EA, so I don't have that one. Then I said substitute it with using stream editorial set with -E for expression, and then say substitute, use this symbol, control V, control M, and then substitute it to nothing, and then globally, and then do this, and then I named it G2.py. And G2.py, now G2.py and G2.py and greet.py are two different files. Notice that G2 is a little bit smaller because it doesn't have the control M characters. So when we did this cap command, this one has all this control M character. When we do G2.py, it does not have control M characters. So we did the DOS to Unix conversion using set. And now if I just run as G2.py, it's going to say permission denied because G2.py is not executable. Say change mode, this time I say U plus X and G2.py. That means make the G2.py executable by user options. So only the user has read, write, execute X. Other people cannot execute it. So now I say G2.py, since I'm the owner, I could run it. I could also say change mode G plus X on the G2.py and run a G2.py ls minus ld G2.py. So whoever is part of the group, in this case, the owner and the group is the same, but group also has permission. If you want to see other, you just say instead of G, O for other. Now the permission of everybody is read, write, execute. So if this was change mode 644 G2.py, originally was G2.py. If I wanted to get all of that one, you could say -AX for all of them. You could say AX, and that is G2.py. It is a read, write, execute for all. But if you wanted only the user -U, if you wanted the group, you just say -G plus X. If you want others -O. But if you change it back to 644 and G2.py, and you decide to say, well, I want to just do this one with one command with octet number 755 is the right one, and then now G2.py is read write executable by the owner, read executable by other, as in groups and others. And you can see the code runs. So this is some of the example I showed you with this. I'm going to move a little bit faster because I have to now show you the variables, data type, if statement, for statement, and while statement inside with Visual Studio Code, and as well as um, the interpreter. We did enough example on the interpreter, so let's just open one of them, even or odd, that might be a big program. So I'm gonna say Python even or odd.py, and then you can see that this is outside of the function even or odd. So whatever is that even or odd program does, that py, it just more even or odd, and that is the program. It checks for this one, it does as a function, and then this is all commented with multi-line comments, but this is a function. You pass in the number, and then it's gonna check whether the number is even or odd outside of the function, but then we did not pass in any argument, so that's why it was checking on it. When you do this kind of arguments, usually do sys.argv and get the parameters from the command line from system. So at this time, we're doing this, and if I just run the same code in 10, 19 outside of the this 20, you could see that it is there. Then even let's go run open it, this one through code even or odd.py. So when you run code, you can run code dot, it will just do that one, or give the name of the file and you say just execute this one. So in this one, I'm going to just delete it to make the program a little bit shorter because they're all commented. We can always just look at those details at a later date. So right here it says num odd number. So between 1 and 10, it should say outside of this one, while number is less than 10. The number is less than 10, it gets the number and then it runs it. So let's see what this the code is gonna do. When you run it here, okay, so for this one, I think I might have to make sure that the code runs with certain extension around the code and debug Python extension. Maybe the extension or loaded or maybe it's not. So let me just say Python interpreter to see if Python interpreter is already loaded. Publisher install sense. IntelliSense is the one, and we say reload required. So this one was not loaded properly, and now we reload it. And then let's look at the code. You can see the syntax a little bit different, the coloring and everything. And then run and debug. Trust workspace. Oh, so you have to trust it every time you do it in order to execute it. And then we're going to just run a Python module. And here's the output that is running here outside of the scope of this function. You can also run it from command line here. So any program like we did the G2, we could say ls minus l g2.py. We could say g2.py, it runs that output. And if we just say Python and g2.py, it will also run it. Similarly, the even or odd. So if I just say Python even or odd, and then it will run, say, outside of the function. So it does happen right here, but it is not doing anything with the main here, because we're not doing any comparison outside of that one, say while num is equal 0. If num is equal 0, obviously num is less than 10, then it's gonna run the even or odd, and it's supposed to do this command. Okay, so outside of the scope of the function, and let me see why it is not making the call. Oh, this is number and passing it num. I'm gonna just read the number here, and so this number, let's see if inside the them, can I just use them? No, actually, I'm gonna try this, and then it's only 3 of them, because these other ones are not defined. And so that's why. And now we save it. We go file, save, and then save all actually. Save this, and then run it again. Now you can see it's doing exactly what it was doing earlier. Let me just say, while number is less than 10. So if number is less than 10, I'm gonna just say 2 is less than 10. I want to see if we don't even look like we're getting into this function. I'm gonna say print as a test. We say we're here. We are here. If we see the message we're here, it goes there, then it should execute the other one, but it doesn't look like it is gonna get there. So file save, and then run it. Yeah, it shows that we are here. Then we're here. So why did it not give the output? Oh, this is just calling it. It's not doing a print statement. So we have to say print even or odd. Then we say whether the number is even or odd. And so now it's going to just give output also. The function, when you make a call, you have to say whether the number is even or odd. So here I'm going to delete this one. We know that that statement execute, and then we can just come back here and do it between 0 to 10. And then here we could even say something like this, F, and then for the number, if it is odd or something, we could also print odd or even. We could do that one, but right now, let's say we want to just make this function call as a output here, whatever is the output should display like that. And then save file, save, and then run it. Now it says 5, the number 5 is odd number, the number 6 is even number, because we pass it on to this. So it has nothing to do whether you define this variable as number. So if I define that one as number, it still should work, because the passing by a name or passing by reference is what is important here. Since we're making the function call with number, and then the num is passed on as a number, it should still do the same thing here. See, the output is the same thing. So that variable name number is getting an argument from this one when it is passed on. This num is coming from between 0 to 10. So if I change this one to 5 to 10, then I get a shorter output compared to the other one. And here's the output. You can see 5 is odd, but let's clear the screen first here. Clear the screen here, and we say run it. Now see 5 is odd, and then before that one, we have to stop it. Let's do something like 15 to 20. 20. So we're gonna just do the between those two numbers and then run it this time. You can see 15 is odd and 16 is even, 17 is odd, 18 is even, and 19 is odd. So you could do say something like that. And then the reason it was not doing it in the first place was because that's printf statement. So we corrected that here. Another way is that right now you learn the if statement. So this one is saying that if number is module 2, the remainder is equal 0, then it must be even number. Otherwise, it's going to be odd number. This function, even or odd, it takes one argument as a number, and that number, whatever a number you pass it on, you just pass it on with this function call, and then you print the output with this format. But because it makes the comparison here, then it's gonna either come out with a odd or even number. And then on this one, it has a shebang Python, but if you want to change that one to say match it with right now, if I run this one, it's not gonna run even or odd.python. It's not gonna run because it's not executable. But if I say change mode 755, that one, and then I say even, I have to get the name of that program correct. So I'm not on that directory. I'm gonna say programs, and then I think it is under the programs, Python, and then chapter 1 through 5. That directory. Let's see, programs. Yeah. I don't know where in this file I stored it from the path. I could look at it, but let's close this one here and then see where this path is. This path is on programs, Python, chapter 5. So if I run this one, even or odd, or odd.py, it's not gonna run because permission denied. And let's minus L even or odd. Similarly to that one for code reusability, I'm gonna say change mode 755, even or odd.py. Notice again, if I say even or odd, this one is not gonna run because there's control M characters. So in order to do this one, I could do an in-place subscript this time. I don't have to put it on a different name. I'm gonna say cat minus EA, actually cat even or odd.py, and then I could have done a set in place. I don't have to even cat it, but let's try that. This time we're gonna do a set in place. We say set minus IE. I means in place, E is for expression, and then the substitution is command, and then we say control V, control M, substitute it to nothing, and then globally, and then the name of the file is even or odd.py. Notice that the argument equal $? It is just zeros, meaning that I did an in place upgrade dash I, E for expression, and then the substitution. I wanted to take control M characters to new, get rid of it. So now if I say cat minus EA, and then even or odd, that one you can see there's no control characters here. Before it was, but now I converted in one command with set command, and then that we didn't have to use cat command. This is shorter form So if you're a little bit advanced on Linux, you can do all these kind of tricks. But at this time, let's see if we just run it, and it's still not going to run because Python is shebang Python is not the valid command there. So if I say even or odd dot py is going to say no such file or directory. Oh, I mistyped it. That's why the even, and then says Python bad interpreter. So I'm going to say vim even or odd.py, and notice that the set list, it doesn't show control M characters anymore because we corrected it. So let's correct the first line. I type in shift:1, it's gonna just go to the first line, and then on first line I could do update it with this command, say shebang, which is this, and user ben env Python. So if I just point that one to Python, now I run the same even or odd, it works. Because head -1, even or odd, it shows that I did it with that syntax. That's how you correct these things on there. And then similarly, if you run it with Visual Studio Code. Now I'm gonna run this one with another way of doing this thing, like code. I'm gonna run dot here, which is means open the current directory. And then I say, yes, trust this one. So I have the executable all working, and this welcome screen is gonna go away. And then here on the terminal, you can just set up different kind of options for view. If you want to see the appearance and the size, full screen and all that thing, you can do that one. But at the same time, I don't like full screen for one reason, that it is just going to make all these options disappear, and then it's really hard to put it back to the full screen option. Last time I did it, it was somewhere here. Let me just see how you take it out of the full screen. I think it was somewhere here, full screen. Yeah, these options should be right away available. It should not be hidden, but it's so hard to find it. But let me see if I can. Last time I figured it out, but I don't remember where it was, that screen, the full screen. So Python, let me close it. See, when you close it, no, this is okay, so go to file and then toggle full screen. So it is F11 or this thing. So you can press F11 to toggle it. That's the full screen getting out. It's hard to just find those shortcuts, right? So now I have this one. I'm going to go back to the code and say even or odd, and then right here I run it, and then I get output based on the number I set. And then here I could say go to 55 to let's say 200 or 200, and that is there, and I'm going to increment it by 10, and so the numbers are really fast moving up here. You can see it's 155, 165, but 55 to 100 is a lot. So I'm gonna say 155 to 200. And that way I have a shorter numbers here. And then incremented by 20 is even better. That way we have only 155, 175, 195, and we're done. So That is one example. Let's look at another one for clearing the screen. We run this one already. You can run this one, and you see that the output is shown based on the commands that we do. The next program that we could look at is example 1.py. Let's see, what is this one? This says enter the first number, enter the second number, then it's going to run them, and then it is gonna divide the first number. The num is going to come as a string. Then you're going to convert it, the data type, from a string to floating point. So you can say floating arithmetic with the division and the number. So like 20.5 divided by 10.5 or something like that. Then you can put it in the result, and then otherwise, depending on what part of the try and exception happens, it will just give you a value. So if I just run this one right now, it says enter the first number, and then the first number, if I say 10, and then the next number is 5, and then now 10 divided by 2 is 5. Similarly, if I just run it and give a different number, 20, as input, and then 10 now should be 2, and that's 2.0. And there was no exception. In this case, this line will run whenever there was an exception or not lost. So we put some kind of else part if it is other part of that code run or not. So then, and there's a details of try and exception. That one I'm gonna cover it on the at least on the maybe data structure, and then intermediate level. That's not the beginner level. So we're going to talk about data types and other ones. Let's just go on to factorial, for example. This function factorial, it just basically get a number, and it's calculating the factorial of it. So it says factorial is equal 1. This algorithm that is going to say if number is equal 0, or whether a number is equal 1, the factorial is 1, or other. So if number is less than 0, no negative factor. But if it is equal 0, then the factorial is 1. Otherwise, you just do kind of a recursive function. You just subtract 1 from it, and then keep going and multiply by itself, and then get the factorial of it. So like 4 would be 4 times 3 times 2 times 1. And then 5 would be 5 times 4 times 3 times 2 times 1, and so on. And then when we run this one, you can see for the factorial, 4 is 24, 5 is 120. Notice at 50, we have this large number. So imagine the larger the number, 100, then the factorial is getting so big. So if I run for 100, this would be like huge. It's going to run your memory out. So look at this one. It's so huge on this one. You don't want to just have like a million here and get the factorial of it. It's almost not available for such a large number. Look at this one, the largest number that you can afford. As long as your memory allows it, and nowadays these large numbers are going to be produced. So same thing with Fibonacci. For Fibonacci, it is basically calculating the first 20 Fibonacci number here, and then I'm also doing a Fibonacci number there. And Fibonacci is the sum of the first 2 number, and then the result is going to be stored there. So if I just run this one, notice that sum of 0 and 1 is 1. Sum of 1 and 1 is 2. And the 1 and 2 is 3. Or 2 and 3 is 5. 3 and 5 is 8. And 5 and 8 is 13. Similarly, if the number is larger, 34 and 55 is 89. Or 13 and 21 is 34. That's how Fibonacci works. And then here, there's the formula that I do. And then here, we are just doing multiple variables and multiple values. So separated by comma, in this case, 0 assigned to A and 1 gets assigned to B. And then we do a while comparison on the A less than N, then we do the A printed, and then this end is just not moving to the new line characters. When you say end is equal this separator, it just gave a space, and then that works there. But if you just say print A, it will print 0, then the next line would be 1. You don't want to do that one. You want to just put this syntax here. And then similarly here, A gets the value of B, and B gets the value of A plus B. So A plus B, for example, in this case, 1 plus 1 would return 2. And then in this case, 1 and 2 gets added to 3. That's how the formula is working, okay? So there's assignment statement, if statement on some of them. Some of them are function calls, some of them are while statement, and then some of them function definition, defining, writing a function. So make sure that you understand all of that one as I go through this, and then I could give you examples as well. Here that we're writing a function, these are called user-defined function. This definition of greet takes 2 arguments as the function greet name. And then you write a function in order to write it once, and then you can call it as many times with different argument and to return different greeting or different messages. So right here, the message W is going to have to say something with first name and last name. Say hello, Wahid Lutfi, and then I will return W, and then printing W will just say hello, Wahid Lutfi. Similarly, if soccer not in W, if the word soccer is not there, then just W.title, just increment titleize it. And then Diego Maradona is the greatest soccer player, as assigned to object D, and print D, and will print it. And similarly, D.find, look for the word Diego in there, and if you found it, you just change it to uppercase. And this is concatenation symbol. This is a method that D has, that the string Diego dot upper is going to say the name Diego Maradona, and say that for example you rock in 1986 World Cup. He actually did. He won the World Cup for Argentina with his teammates, but the majority of work was him. Everything on every game, he accomplished so much as a superstar player. And then the same thing for Messi. Last World Cup, they won against France, and Messi did all the job, and he's a great player as well. Except the difference between Messi and Maradona, there was no Maradona in front of Maradona. Messi watched Maradona, and then a lot of stuff that Maradona did, Messi did that, plus whatever Messi had differences, like his own unique skills as well as Maradona's skill. So it's not like Messi is superset of Maradona, but Maradona was like one of the stars that invented all these tags, and he told like the soccer ball how to obey him. Every instruction he did it, the ball understood him. And then Messi learned from that one, and Messi is mastered it also in the same way that Maradona did. So each one of those ones, some people compare them. I never compare them. Each one of the best soccer players, whether it's Maradona, Cristiano Ronaldo, Messi, John Cruyff, Beckenbauer, Zidane, Ronaldinho, Ronaldo, all of those greatest soccer players, Zico, a lot of them, Dr. Socrates, God bless them all, that passed away, Gerd Muller and Eusebio and other ones. But they were all great soccer players. They all had their own values. And so let's go to the next one, and then we did this one already. And the first name, this one, It's basically creating a first name, assign it Wahidullah as value, last name Lutfi, and then favorite sport is soccer. Then it says that your favorite sport is, and then that's the string, and then say hello that person name, hello word one time, and then the next time it says hi Wahidullah Lutfi, your favorite sport is soccer, and that's how the output is shown here. So based on these values. So these ones are basically showing the variable with some data type and then some statement to output it, whether use the F string or print a statement or concatenate them or separate them by comma. Each one of them has its own syntax. This is a multi-line comment, and then this is another multi-line comment. You see multi-line comment start with the single quote or close with single quote. So you can have multi-lines. I just gave one line, but you can have multi-lines here. So if I just go here and say just escape and then say YY, actually I don't think I'm inside VI on this one. Maybe I didn't load it, but you could just add a line here. Say, and this is another line. So you could do that one, and then similarly this one. So multi-line column, you could have as many lines as you want. That's not have to be string. Here, hello word, and then hello. This is one. When you run this one, first it says hello world and no space when you run it, and then when you do it with comma, there's space, and then the subject and everything else that you want to do. And if you want to see the actual output, I have to move this one out. You can see that it's without the a space. When you print this one plus is 2, this is what it's doing it. Here's when you put comma, there's a space here. And if you just do separate them by a space here, you could do the same thing right here. And then the last one is 1, and then S2 is the space, and there you could do that. And then there's more on the bottom one. So this is the bottom ones for class, and that's in good evening classes, good evening, good morning class. This one is some comparison for the if statement. So for the if example, you can see that this is a multi-line column. So the code actually that I have here is a while statement. Everything else is commented. As you can see, it's highlighted in different color. So the only code that runs here on this one, x is equal 10. When x is less than 10, it prints 10, 11, and 12. Then when it's 13, it breaks. So this is 10, 11, 12, 13, and this code runs. If I just change that comma here, and I want to print this list here in the state, I could move this here, and then and just take actually move this one out, and then right here I can say comment that one out. And so everything above is comment. This is the only part that is not commented out. So I'm declaring a list, say fruit, and I define fruits of 0 apple, fruits of 1 pear, and so on. And the last one is banana. So then I say while I is equal 0 for every fruit, and go through the list when it is less than 4. So this is 0, 1, 2, 3, 4. The last one is 4. Then it says print the fruit and then incremented and until all done. And notice this one, I don't want to comment it, so I want to run this line of code. And so this line is commented from the above, but this is line 33 to the bottom will be executed. And now it says 0 through the 4. If I change this one to, let's say, only print up to grape, then I just do this one, and then I don't get the banana because the 4 is not included. This is 0, 1, 2, 3. 3 is included, so less or equal. If I just change this one to equal, then now grape is not included either. You can see here. So the code is very flexible. You're writing it. This is a for statement that you could do that. Okay. There's a lot of other examples. Import example here. I'm doing math modules with random and everything. You could see it, you could run it. The code is there. So I'm running a math module as m and then random, and then get the power of 2 to the power of 10. That's 1024. This is square root of power of 2 to the power of 4 is 16. Get the square root of it is 4. So the output of that one is 4. If I just get more of them, shoot. Okay. So right here, you can see that the outputs are based on the value that I'm printing here. Clear screen. If I just say clear, and then now I run it, and the output are showing here. So 1024 was the first one. The square root of 16 is 4. And then the same thing with the enter num is equal that to print all the random numbers that I generate here between 1 and 10. And then also between a range of 20, we're printing it. So different numbers, different values here, depending on what we do. The multiply function is doing another thing. So this one is multiply. It takes the argument, arg, k args there, and then we're just getting a pointer to a pointer. So this one, it gets the value and then multiply it to itself. And then that's a multiply function. And then here we just get a list, whatever the list, we multiply it to itself, and then the same thing here, get this list. Rather than passing it into that, we just get a tuple as a number, and then call the multiply functions to say, because the argument, that store argument, that means one or more argument. And that you don't have to have a specific number of arguments. Here is between 4 arguments. So each one of them you pass in, you get a different set of values. My OS, we already checked it. My sum, this is similar for the summation. We did the addition, now this is the summation. I mean multiplication, now it's summation. So you could write these functions and your own user-defined function, but they are also available on the Python interpreter itself. You have some of this function like product or PAL, or using the math.pal function. There's also PAL functions. I showed you on the Windows side also, but it's getting really long and I have been talking forever on this one. I'm gonna just jump into vars here. Let's say on the vars, we're defining a variable Python 2, and then you're going to run this one, and just to show you, and the outputs are here. At this time, these informations are all there. I'm gonna exit out of this one. I'm gonna run one more code. Let's say for more var1.py, and then say Python var1.py. So here you can see I'm loading the math module, import random int, and then I do print to the power of 10 is 1024, and then to the power of 4 is square root of that one is 4. Out of 16 is square is 4. And then this is random 1 to through 10, and this is a range of rand int of between 20. That's a bigger number. So you can see 1024, 4, and then the random numbers, they're there. So let's just do a couple of things. Vim var1.py. I'm gonna just say 2 to the 10 power of 4. I'm gonna just do this number smaller. So I'm gonna say 2 to 5. And then this one, not 20 of them, I'm gonna say, let's do 5 of them. And then here a random of 5, actually 8. So between 5 and 8. So let's see if we run the same code here. This time we get shorter values because var 1.5, we have that, and then here, and the output is that. You can see that the first two was that, and then the next one, and then between 5 and 8 was just finding twice. And notice that every time you run the random number generator, it had a different set of values. This time we got 5 and 6, and this one got 0, 7, 2. So depending on the code, a different random number generator there. But the square root of 16 is always returning 4. And the power of 2 to the power of 5 is always going to return that. So now I'm going to run which Jupyter underscore lab. And this time Jupyter lab. Yeah, so if I do which Jupyter-lab, it's already installed. If it is not installed, you can do pip install in Jupyter dash lab, or just Jupyter-lab like that. And then it will just say that the requirement is already met and dash lab. Default install pip. Let me see what is no matching distribution for Jupyter. Jupyter, I must have typed it right. Jupyter dash lab, and then Jupyter no dash. Yeah, the Linux version, it works on this Jupyter-lab, but the actual binary is called Jupyter dash lab. On Windows, it is whatever the name is, you just get that one. So I'm gonna say Jupyter dash lab. I'm going to start Jupyter-lab here. This is another tool that I want to use this way. In case this is better than the Jupyter Notebook. So under the setting themes, I could increase my font here. And so you look, it looks better for you. Increase font, and then one more time, maybe two more time. Oh, sorry. Increase theme, increase font. So now it's better here. We could just say, do this one, and then I could say, and just let's do some number. I could say for num and range of let's say 10, we're gonna just say so print. I'm gonna say f, and then I'm gonna say num. So whatever is the num is nums times num is equal, and then is equal. I'm gonna just say num times num, like that, and then close this one, and then close this. So when we run this one, if I run this cell, it should run, say, the 0 times 0 is 0, and 1 times 1 is this. So now you use the for statement to go through a range here. Or you could just say a different set of numbers. So here I could say, 10 to 100 increment by 20, or increment by 20 is good. So at this time, for each time that 10 is going to have the number, it would be 10 and then 30 and then 50 and so on. So you could see that 10 times 10 is 100, 30 times 30 is 900, and 50 times 50 is 200. You could do this one. At the same time, on the above statement, you could also do a list comprehension. You could say x is equal, say x for x in range of 10, 100, 20. This would do it as well. And then say print x. Notice that since I print x, it's gonna just print it horizontally next to each other, that number. But if I just say x, it will just be printing x, it will just print it a line vertically. Or and printout is just that list there. Print x is not gonna work because this is Python 3, and then on the older version, Python 2, you could do it that syntax, and it is the format. So at this time, you could also do something like this. So if I just delete these x values here with cell, notice how nice it is, this tool. You could do it print like this, or you could say, let's say from this one to 100, you could say a if statement. If x module 20 is equal 0. That is saying the same thing, increment by 20. So that is going to print the same value, 0, and then 20, then 40, then 60. So whichever one, the value one, you do that one, then it will do the increment of that number. If you would say mod 2 now is equal 0, this is going to print all the even numbers. So this one is going to show this. If it's not equal to, and then it's all the odd numbers. So let's say you want this one between 0 to 10, that is a shorter number, you can get this list. And then here, if you don't want to do that syntax, you could also say something like this. You say, let's say for x in range, use the range method, and then this case is 10. You could say if statement inside here, but it's not as fast as the list comprehension, because list comprehension is using like lambda kind of functions, so you could do it faster that way. And right here, we could say if x is mod 2 is equal 0, and then say if print if the even number is, and then you just say x. You print the x, and then there you go, and then else you just say the odd number is, print f, and we say that odd number is, and then just do again x followed by that. Now you run this one, and this cell, when you execute it, you see that the even number is 0, the odd number is 1, the even number is 2 and 3, and so on. All of them, the 9 is odd and 8 is even, 7 is odd, 6 is even, 5 is odd, 4 is even. You could do that one. And if you just wanted a shorter one, so you could see between that number up to 5, that's good enough. Up to 4, you get the value. If you want to include the 5, you have to do 6 because the last number is not included, -1. So here you can also, I told you that this is faster because of lambda function. And then here we did this one It is much easier to make a way that you write your code and do anything you want to do. It is your choice, basically. On the Linux, you can also create a list, say commands is equal, and then let's say on the list of the commands, I want to say run the calendar command, run the date command, and run the who am I command. And then that's 3 commands that we want to run this one. And then I say print commands. This one is just showing me the list. So if I just run that one, it's showing that. And then I say for CMD and commands. And then I say, well, print commands, print CMD, that's going to just show the string command that I'm going to do it. But if I say for this one, let's just import the OS module and say import OS module, and then I say os.system and then run the command. We could just execute that one. Now each command is running. Calendar command is there, the date, and then since I'm doing the system, it returns a value of 0. If I don't want a system, then I have to do something like stream is equal os.pipe open, and then just cover the command here, and then say output, I'm going to say OP for output, and stream dot read function, and then right here I'm going to say print output, and this one will do that one for me. So now I just run this one. Notice the calendar command is there, and then the date command, and then the last command, which is the who am I output. You can also here say F and then double quote here or single quote, but whatever you started here, you could say this time is CMD followed by the output here, followed by the output. And that one. So the command and then the output. So let's see if we run this one. So calendar is the command and the output is here. Date is the command, output is here. Who am I is the command, output is here. So you could do anything you want to do. I'm gonna end this video because it's 12:08. I need to sleep also and have to go somewhere early in the morning or just do stuff. So I hope you enjoyed it. I hope you learned something from it. Please let me know, make some comments on the videos. Please subscribe if you haven't subscribed. It will also benefit me on making all these videos for you guys that are watching it. If nobody watches it, nobody subscribe it, I would just get discouraged, and then you will not benefit anything either by not watching it. And then if I make these videos, usually when you learn from it, you might pass on the knowledge to somebody else, or you benefited at your work or your school. Take care. God bless you all. Bye-bye.